Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Utah 03 and it's by Red Barchetta. And here are the rules. Well, we see Utah, so this is Utah here. Um, I don't know the cities. I'm guessing this is Salt Lake. I don't know what this one is, Ogden or something. Anyways, let's get to the rules. We have normal Sudoku and normal variant rules apply. So normal Sudoku rules means that in every cell in the grid, place a single digit from 1 through 9, such that there are no repeats in any row, column, or designated 9-cell region, which is a box. We have arrows, where digits on an arrow sum to the digit in the bulb of the arrow. So, for example, this digit is the arrow, so that sums to what this digit must be. Same with this digit, so that should tell you something. We also have a palindrome, where digits on gray lines repeat forwards to backwards. For example, 1, 2, 3, 3, 2, 1 is an example of a 6-digit palindrome. So this would have to be read the same this way as it does this way. That should also give you some information there. We have Renban lines, where digits on purple lines are a set of consecutive digits without repeats in any order. So for example, you could have something like 6, 5, and 7, and that would be valid because these three digits must be consecutive. Or must form a consecutive set. That's probably a better way of putting it. What could not work would be 5, 6, or 8 because, again, these don't form a set of consecutive digits, right? 5, 6, and 8 5 and 6 are consecutive, but 8 is not consecutive with either 5 or 6. So that doesn't form that's not valid as a Renban line. And finally, we have digit xv, where digits separated by an x sum to 10. Digits separated by a v sum to 5. And all xv clues are given. So that's a negative constraint, which means that we are constrained by the negative implication of what not having an xv would mean. So, for example, if this were, say, a 3, this would have to be 2, and this would be 7, because those two digits must add up to 10. These two digits must add up to 5. But, say we had a 3 outside that's not next to an x or a v. That would mean 7 and 2 cannot share an edge with this 3 because there is no x or v around this cell. So therefore, these two cells, these two cells, these two cells, and these two cells cannot ever add up to 5 or 10. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. First things first, I like in these type of puzzles, especially when the XVs are all given, so we have the negative constraint in place. I like defining things as 1 through 4 and 6 through 9 ideally. If you can't have 6 through 9, 5 through 9 is also fine. But being able to differentiate between all of those is very key. So all of these are 1 through 4. Anything that's next to a V must be 1 through 4, right? Because you can have either two digits adding up to 5, which would be 1 and 4, or it's 2 and 3. So these are all 1 through 4 because they're next to a V. Well, what are the remaining digits in boxes or cell or columns or rows which all have 1 through 4? We know they have to be 5 through 9. So we're looking for any rows, columns, or boxes which are already have 4 digits, 4 cells that must contain the digits 1 through 4. Well, this is pretty simple. There's a whole bunch of them, actually. Row 2 satisfies that, so this is 5 through 9. But let's go through the more obvious ones. Column 3 has the rest of the digits must be 5 through 9 because we have 4 digits from 1 through 4. Therefore, these are all 5 through 9, and because of the palindrome, these must be the same as these cells. So these are also 5 through 9. Well, this cannot be 5 because it's next to an x, and x, any digit next to an x would have to be, cannot be 5 because 5 would have to add with 5 to add up to 10. So for this 10, since this is 1 through 4, this must be 6 through 9 here. This must be 1 through 4 to add up with 6 through 9 to add up to 10. So that's important. Well, I don't know if it's important, but okay. So this is 6 through 9 because it must add up with 1 through 4 to add up to 10. We have in row 8s and row 9s, the rest of the digits are 5 through 9. Actually, let's not do that yet. Let's start. Okay, so now here, we don't have enough early information about the 5s and 9s to really disambiguate things. So we should start coloring the 1 through 4s and their corresponding 6 through 9s. Because the way that, if that works, then we can use the negative constraint of the all xv clues are given to figure out where those can be. So we just basically randomly choose colors that we feel like fit. So I'm going to make this blue, orange, pink, and green. So this can't be blue-orange. It must be the green-pink set that adds up to 5, right? This can't be blue-orange because there's a blue in the row, so this is also green and pink. This cannot be orange, those must be blue, which makes this orange. It can't, yeah, we can't be green, pink, or orange low, so this must be the blue low. This must be a green-pink pair. This is green or pink. Do I want to do it this way, though? I don't know if I do. This is a green-pink pair. So since this is green and pink, this also must be, this cannot be green or pink because if it were, it would add up to, there would be a V in between these, and that's not possible. So this must be blue and orange. This is a blue and orange pair. This must be the green or pink pair. This can't be green because of the green in the column. So this is pink, which means this is not pink. This is green. This must be the same as that. So this is pink, which forces this to be green. These are either blue or orange. We're not sure which. And this is a blue-orange pair because the low digit cannot be green or pink because the low green or pink is here. And there must be a low digit for 2 digits adding up to 10. There's a digit from 1 through 4, and there's a digit from 6 through 9, right? So one of those is low. That means the remaining digits in the central box are 5 through 9. These cannot be green and pink because this is a green pink here. So this is blue and orange. That means this is blue or orange here. This must be a green pink pair here. This must be a blue orange pair because we have a green pink pair already that are low in the box. So this is blue or orange also. Well, this is a 6 through 9 because it's next to a 1 through 4, and it has an X separating them. So where's the last 1 through 4? It must be here, and this must be a blue or an orange. We're not sure which. This cannot be blue or an orange because that one of the blue or oranges is here. So this must be green and pink. This can't be green, so this must be the pink low, which makes this the green low here. This digit must be 5 through 9. Well, if this is 5 through 9, 5 can only be on a Renban with 3, 4, for 3 cells with 3, 4, 5, 4, 5, 6, or 5, 6, 7. Obviously, 5, 6, 7 is not going to work. Because this can't be 5, 6, or 7, but 3, 4, 5, and 4, 5, 6 work. So this is 5 or 6 here. This has to be pink. This digit cannot be 1 through 4 because we have all the 1 through 4s in that column. Therefore, this must be a 5, 6, 5, 6 pair, which forces this to be 4 to be on a Renban with 5 or 6. That means be consecutive digits, or form a consecutive set of that. So that means all the pinks are 4. So this is 4, this is 1, this is 4, this is 1, this is 4, this is 1, this is 1, that's 4. So the green-pink pair is 1 and 4. So these are all 1, 4, 1, 4, 1, 4. This is 6 or 9. And all the blue-green pairs are 2 and 3, right? So this is 2 and 3, 2 and 3, 2 and 3. So this is 1, 4, 5, 6, 5, 6. That means this can't be 6 or 9, 7 or 8 to be next to the 2 or 3. Same with this. This is 7 or 8. We have a 7, 8, 7, 8 pair in row 6, which eliminates 7 and 8 from the rest of the rows. This can't be 7 or 8. It's 5, 6, or 9. Okay, so we can remove kind of the green and the pink shading for those because these are essentially set. Now, I guess let's make these green and pink. So this is pink, this is green. That means this is pink and this is green. Pink cannot be here. Pink is either here or here. And in the box, okay, this has to be blue or orange. This is blue or orange. We now have 4 cells in column 4, which are blue or orange. So this must be the last blue or orange, and it must be 7 or 8, which makes this 2 or 3. That means this cannot be blue or orange. It can't be 7 or 8. This is 5, 6, or 9. This is 5, 6, or 9. Obviously, 9 cannot be next to the 1 because they would have to have an X in between. 6 can't be next to the 4 because this would have to be a... there would have to be an X in between there if that's the case. Okay, so these are not helpful as colorings. So we're gonna essentially remove all those and use a better set of 2, 3 pairs to mark those. So we're gonna mark these as blue and these as orange. That forces this to be the orange low. This is the blue low then. This is blue for both, so these must be orange. That forces this to be orange and this to be blue. So this must be a 7, 8 pair here. These have to be blue. A 2, 3, 7, 8 pair. This is blue, this is orange. Okay, so this cannot be the high orange. Where can the high orange be? Well, this can't be high orange. It can't be high blue either. So this is 689. Sorry. 569, and because of the the palindrome too. So this becomes 1 okay, so yeah, this should have been both green. Okay, well there you go. This is 1, this must be 4 because the palindrome. So these match. This matches that, this matches that. This is 4, so this is 1. This can no longer be 6 here because there would have to be an X in between these. This can't be 7 or 8 because this can't be 7 or 8 and it's a palindrome. This can't be 6 because it would be next to a 4 here, and these are the same digit. Okay, so we can remove these greens and pinks because of the palindrome. So this is done, this is done. I guess let's mark these still green, and these are pink. Okay. So where is green in row 5, or specifically the 1? Cannot be here because of the 1 in the box. Can't be here because of the 1 in the box. Can't be here because of the 1 in the column, so it must be one of these. So this must be a 1-2 pair to be a Renban. I guess we don't need the greens and pinks anymore. That forces the orange 2 3s to be 3 because it cannot be 2 because of the 1-2 pair in that row. So this is 3, which forces the orange highs to be 7. The blue lows must be 2, but we don't know about these. So these are 2, and the high blues must be 8. Okay. This can't be 8 anymore. This can't be 8 anymore, and neither can these two. Neither can that. This must be consecutive, and it cannot have 1, 2, 3, 4, 7, or 8. So this has to be a 5, 6 pair, which eliminates 5 and 6 in the rest of the row. This can't be 5 or 6, so this is 9. This can't be 5 or 9, so it's 7. This can't be 5, 6, 7, or 9, so that's 8. The 9 eliminates 9 here, so it's 5. This can't be 5 or 9. That's 6, which makes this 9. That's a 1. This is 4. This 1 eliminates 1 here, so this is 2 and 1. This 7 means this has to be a 7 because of the palindrome, so these can't be 7 here, here, or here. 5 cannot be here because of the 5 in the column, so this can't be 5 either. This digit must be 5 through 9. And this cannot be 1 or 4, so this is also 5 through 9 to be next to it on a Renban. So this has to be 6, 7, or 8 because it can't be 5, because it can't be next to an X if it's 5, because they would have to add up to 10 with another 5. So this is 2, 3, or 4, cannot be 6 and 4, obviously, because of the 4 in the box. So this is 7 or 8. 7 and 8 is only consecutive with 6, 7, 8, or 9. So these are consecutive there. This 9 eliminates 9 here, so this is a 6, which makes that a 6. That means these can't be 6 because of the palindrome. The rest of the digits in row 4, these have to be a 4, 5 pair. This can't be 4 because of the 4 in the column, so this is 5 and 4, and this is 9. This 1 eliminates 1 here, so it's 4 and 1. This 6 eliminates 6 here, so this is 5. This can't be 5 or 9, so that's 6. Last digit here is a 9 because in the lower central box there was no other digit. That means in column 5 this has to be a 5. In column 6 the remaining digits are 7, 8, and 9. This can't be 9 because there's no x in between that and the 1. This can't be 8 for the same reason between the 2. If this were 5 and 6 as the Renban, one of them would be consecutive, or would be adjacent to a 4, or share an edge with a 4, and they would not have an x in between them. And one of them 6, obviously, if that's the case, so this cannot be 5, 6. Same with 6, 7. Could be 7, 8, or 8, 9. So either way, this is an 8. That means this is 7 or 9. Rest of the digits in row 9 are 6 and 7. Well, if this were 6, it could only be consecutive with 5 or 7, but because of the 6, 7 pair, can't be here. This has to be... This can't be 5 because of this, of 5 in the column. So this doesn't work as 6. This has to be 7, which makes this a 6. That makes this an 8. This 7 eliminates 7 here, so this is 8 and 2. Actually, we had a 3 here, so we should have known that already. This is 7 or 9 here, so it cannot be 6 or 8. This is 7 or 9. That means 9 cannot be 9 here, so this is 5, which makes this 9, which makes that 5. That makes this not 5, so it's 6, this is 5. That makes this 6 and 5. This 9 eliminates 9 here, so it's 5. Remaining digits in column 1 are 3 and 6, but this can't be 3 because of the 3 in the row, so this is 6, this is 3. Remaining digit in row 2 is an 8, so this is 8. This can't be 8 anymore. Where's the 8 in column 6? It must be here. This can't be 2 because it's next to an 8 and there's no x in between. So this is 3, this is 2. That makes this 2 and 3. We have 8 2s. We know where the last 2 has to be. It has to be here. I think we have 9 1s, right? Yep. So we have all the 1s. We have 8 3s. We know where the last 3 has to be. It has to be here. We have 9 4s, so that's set. 5s, we have 9 5s, that's set. 6s, we have 8 6s, so we know where the last 6 has to be. It has to be there. 7s, we have kind of limited information. So let's do 8s. We have 9 8s. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 9s, we kind of have limited information too. Okay, so the rest of the digits either are 7 or 9. The question is, where can they be next to? This can't be 7 because it can't be next to the 3 because there's no x in between them. So this is 9, this is 7, this is 9, 7, 9, which makes this 7, which makes that 9, which makes that 7. Oh my heck, good gravy, you did it. Next up, Zion, which I believe is a reference to Zion National Park, yeah, I think it's in Utah. Heard it's very beautiful, actually. So, anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.